In this lecture, I'm going to show how to achieve the same data manipulation performed by pivot table in the previous video, using instead unstack on a multi-index data frame. Then we are going to explore data transformation and aggregation using group by. We start by promoting the columns containing strings to indexes, as previously shown. Then we use XS to select a cross-section of the rows, specifying the labels of the index levels 0, 1, and 2, corresponding to the unit, kilograms per capita, the hazard, non-hazardous, the waste category, plastic. Then we use unstack, with the level option equal to 0, to promote the outermost index level, that is the operation, to the innermost column level. Unstack performs a transformation similar to pivot table, but operates on hierarchical index levels. Finally, using lock, we access the countries and the year we are interested in. We can also look at 3 waste operations and compare 2 different years. The column waste treatment stores the total mass of processed waste. It would be convenient to express the masses as percentages of the total. The transformation can be done using group by. This method splits the data frame into series, or smaller data frames, along specified rows or columns. Here we select year 2014 and group by country. The data frame is split into series, each containing the data of a single country. Group by returns a tuple. The first object of the tuple is the name of the group. The second object is the series or the data frame. With transform, we pass a lambda function which divides the mass values of each country in a given year by the last of those values, that is, the waste treatment value. Whenever this value is missing, we get an error float division by 0. To avoid that, we add a conditional statement to the lambda function. Now, for example, the table clearly shows that the percentage of plastic recycled in Greece has doubled from 2010 to 2014. Group by can also be used to aggregate values. Here we want to compute the sum over the EU countries, which are currently 28. This aggregate is called EU28 and is already stored in the table. However, now we want to calculate it ourselves. First, we drop the countries that are in the table but not currently in the European Union. Then we group the data frame by operation and we sum over the countries. Our aggregate EU28 is quite close to the one in the original table for most of the operations. The discrepancy that we see for the energy recovery is due to the fact that the data for Luxembourg and Austria is confidential at the country level, but included in the EU28 aggregate. Data aggregation on the groups can be performed with custom functions, using aggregate, often called agg. For example, here, we calculate the average over the available data. It is also possible to specify for each column the type of analysis that we want to perform. For instance, for the years 2014 and 2010, we calculate both the mean and the standard deviation. To conclude this lecture, we are going to briefly look into the basic usage of the merge function, which allows us to join 2 datasets together. We first copy this small table containing the amounts of plastic waste treated in 2014 into the data frame TRT_2014. Then we repeat the same steps that we have applied to the waste treatment data, this time starting from the dataset on waste generation. We store in gen_2014 the amounts of plastic waste generated in 2014 by different activities in Sweden, Italy, Greece, and the European Union. When we call the function merge, we specify the data frames we want to merge, the one on the left and the one on the right. We write how we want to merge them and according to which common keys. In this first example, we create the union of the two tables. We write how equal to outer, and we use the indexes as common keys. TRT 2014 and Gen 2014 do not store data on the same countries. Specifically, Gen 2014 has the index key EU28, but not DK. When we create the union, the corresponding fields for waste treatment are automatically filled with not a number. As a second example, we create the intersection between the two tables. We can also preserve the index keys of either of the two tables by writing how equal to left or how equal to right. This video concludes our series of lectures on the PANDAS library.